Hello class. We'll start with the question which is given to us. That on a horizontal surface which is smooth horizontal surface, there is a rod of mass 24 kg which is being rotated about its center of mass. Center of mass of rod is at rest. Now at a distance of L by 3, where L is the length of the rod, there is a particle of mass small m. There's a particle of mass small m which the rod makes a collision with. That point of the rod will make collision with. So if this is the rod, this is its center, then at a distance L by 3, which is this, from its center there is a mass small m located with which this point will collide, this one. Post collision, translational motion of the rod has not been commented on, but rotational motion is ceased. So rotation comes to a cessation post collision. Let's try use coefficient of restitution equation to get speed of the bodies post collision. One relation that we'll have between the speed vis-a-vis coefficient of restitution is v with which mass small m starts moving. Rotational is ceased, translational is still on, so v prime with which the point will move, it will move with the same speed as the center of mass of the rod, right? We'll divide by, now before of collision we are aware of what was speed of mass small m, that being 0, and point which makes a hit with small m was moving with omega L by 3, as initially rod was made to rotate about center of mass. Given to us is an elastic collision, which is to write E1. From here we get one relation between V prime, V minus V prime is equal to what to us? Omega L by 3. This is one equation which we get from energy equation, which are of course with a half mv square. If you go ahead with, you won't get an exception, but it will be quite circuitous. I'm not going into the onerous path. We did by coefficient of restitution, the easier way out. Next, conservation of linear momentum is certainly on. So m into v is now the momentum of mass, and momentum of rod accordingly will be m, capital M into v prime, right? This is the momentum of rod. Rod is only translating post collision. So m into v prime is for rod, m into v is for mass. Initially, what I'm to write for center of mass of the rod, 0 not moving. For small m, 0 not moving. Do check. This is post. After of hitting, what is to happen there is to be known to us. mv will move with, but be very careful on this v. Now post collision, first we'll have to calculate which is the point about which mass can be said to be at rest. This rod ICR, if I am to calculate about which rod will be assumed to be rotating post collision, we use equation k square is equal to AB here. So L square by 12 is equal to what to us? the point of impact, L by 3 into x. It gets us x is equal to L by 4. So this is L by 4 from the center of the rod. And when we write V, what will be momentum of the body, so momentum of the body, if you calculate from that point, just before of hitting that point was moving with what speed we get to know, omega into L by 3 plus L by 4. We can from there figure it out. But for now, I'm writing equation for conservation of linear momentum. So mv, with which the body is moving, center of mass is moving with v prime. So mv prime, center of mass of the rod post collision, mv prime. And v prime, if we require, we can write in terms of omega later. Not for now. We can go ahead with this equation. This is the momentum post collision, and momentum of the system before of collision. What was it? It was moving about center of mass. Center of mass was at rest. So no momentum for rod, no momentum for mass. Okay. Next, what about conservation of angular momentum? Conservation of angular momentum for the rod will read ml square by 12 plus ml square by 16 whole into, let's say it was rotating with omega, right? Mass wasn't moving, so it will not have any momentum, angular momentum about ICR. Post collision, mass starts moving, rod ceases to rotate, so omega 0, mass starts moving with v, so mv, and the distance is L by 3 plus L by 4. Okay. Now what? We can get relation between m prime, small m, capital M, v prime from question number 2. So let me change for v prime or v. So v prime is from here, v prime from equation 2 will be minus of mv divided by m. Placing it in equation 1 gets us v minus plus mv by m is equal to omega L by 3, which is to get us 3 times capital M plus small m into V divided by capital M is equal to omega L. Let's place it in equation number 3, ml square plus ml square by 16. And for omega, we place thrice of capital M plus small m into V by ml. To the right, we have mv allowed 1 by 3 plus 1 by 4. So far so good. M by 4, if we take out 1 by 3 plus 1 by 4, and this will be thrice of m plus m, I'm keeping it as it is, into v by ml is equal to mvl 1 by 3 plus 1 by 4. So this gets cancelled, m and m gone, and there's an L as well, right? L square, I presume there was an L. So this L got cancelled, so there was an L, and that L got, is to see cancellation nonetheless. So we get from here, now this V also gone. So we are left with thrice of capital M plus small m is equal to 4 times small m, which to get small m is equal to 3 times capital M, which is 72, as capital M is 24. Thank you for indulging me with this question. The other part of it, you can contemplate three leaves. Try brooding on the second part. This is question 56 at the top of the discussion. We want to mention question number 56.